Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 11. It says in the circuit below, the battery has an EMF of 12 volts. The battery and the connecting wires have negligible resistance. Then ammeter A2 reads 1.5 amperes. You can see the circuit below here. And then 11.1 says calculate the total resistance in the circuit, only for 3 marks, right? So now, having to observe everything that we are given the EMF, which is 12 volts, and then we are also given the total current here, which is read by ammeter A2. It's 1.5 amperes. Now, obviously, to calculate our total resistance, we now understand that we have to write the formula. So R total is equals to V total over I total. Our V total is the EMF, which is 12. And then our I total is this 1.5 here. And if we say 12 divided by 1.5, we get 8 ohms. And then for a 3-mark question, that's perfect. Formula, substitution, and then the correct answer with the correct SI unit, right? And then let's proceed. We have 11.2 says determine the reading on A1, right? Now, if we say our current is moving like in that direction, at this moment, we can see there's a split of current, meaning we are starting with our parallel branch. So the current passes through A1 and then passes through the 2 ohm resistor, which it's following the same pathway to another 2 ohm resistor, meaning this 2 ohm resistor and this 2 ohm resistor, they are in series, but then here there is a split of current to the other direction, right? But then remember, this is a parallel branch. So what do we do in this case? This 2 ohm and the 2 ohm here must then combine to form one big resistor that will be parallel to this 4 ohm resistor, right? So this one, we say that in a parallel branch, but then they are in series. So what we can essentially do here is just take the 2 ohm and this 2 ohm, combine them to give us 4 ohms, right? Now at this point, this is what we understand. We do understand that the I total is equals to the current that flows in the series, and then which is equal to the current that flows in the parallel. So the sum of the current that flows in the parallel. Now, if we are taking this 2 ohm and 2 ohm to form 4 ohm, and then also this one is 4 ohm, what we do understand is that if we are saying that resistors in parallel share the same potential difference, then we also say that their resistance are equal. Then it goes without question that also the current that they have to share amongst each other will have to be the same. So that means, in other words, they would have to split this 1.5 amperes evenly, right? So how do we split the 1.5 amperes evenly? This is how we can do it using our ratios. So we want to say the ratio of the 4 ohm resistor, this one, to the other 4 ohm resistor, which is a combination of this 2 ohm resistor and the 2 ohm resistor, will obviously have to give us 1:1. Now, if we want the current that flows on A1, which is obviously the current of these combined resistors, then we would have to say 1/2, then multiplied by the total current of 1.5. Right. Now, 1/2 multiplied by 1.5 is going to give us 0.75 amperes, meaning by saying that this current is being split evenly, we are saying here we're going to have 0.75 amperes flowing, and then also here between these 2 resistors, we're going to have 0.75 amperes, right? Now, because they're connected in series, we do know that if this 4 ohm is 0.75 amperes, then even if you break them apart, it's still that 0.75 amperes, right? So the A1 here is responsible for the current that flows in the 2 ohm resistor and that 2 ohm resistor, right, which is 0.75 amperes. And 11.3 says calculate the reading on voltmeter V1. Now, how do we calculate the reading on voltmeter V1. Now that we know that here we have a current of 0.75 amperes, right? So remember, because they're in series, that's 0.75 amperes, and also as well as here 0.75 amperes. But then to calculate the reading on V1, we would say 11.3, that's V1, is equals to the current multiplied by the resistance. Now, what is our current? It's 0.75, but then our resistance is 2 ohm. So if we say 0.75 multiplied by 2, we end up with 1.5 volts, right? And then 11.4 says calculate the resistance of resistor B. Now, how do we calculate the resistance of resistor B? We can do this. Now that we already know of this one here, all the resistors in here, we can try to calculate this here. So this, remember, we got 1.5 volts. And then if this one is the same information, 0.75 amperes, and also here we can tell that it is 2 ohm again, then that means this resistor and this resistor are all equal in everything. So that means we also have 1.5 volts. But then remember, we spoke about having to combine these two resistors to form one big resistor. If we combine these two resistors to form one big resistor, because they are connected in series, we would have to add their potential differences, right? Because now if they are combining to form a 4 ohm resistor, this one is coming with the voltage of 1.5 and that one is coming with a voltage of 1.5. But then we know in terms of the resistors that are connected in series, we have to add the potential differences, because we call those ones the potential difference dividers. Then if these ones combine to form a 4 ohm resistor, so if we have a situation like this whereby we have 4 ohm and then that 2 ohm and that 2 ohm combine to give us a 4 ohm resistor, that means the total voltage that will be flowing in that combined resistor would have to be 3 volts, right? But then since this 4 ohm will be in parallel to this other 4 ohm here, then that means this as well needs to be 3 volts. Why? Because the potential difference of all the resistors that are connected in parallel is always the same throughout. So if we have 3 volts here, and then we say this is connected in parallel to this other resistor, then this other resistor needs to be 3 volts as well. So now, in other words, we can conclude that by virtue of adding the voltage V1 plus V2, we have found V parallel, right? So by saying 1.5 plus 1.5, then our V parallel becomes 3 volts, right? And then since we do have the V parallel, we can use the formula that goes V total is equals to V parallel plus V series, right? And then now our V total, we've been told, is 12 volts. That's the EMF. But our V parallel, that's 3, and then we have V series here. So for V series, we need to say 12 minus 3, which will give us 9 volt. But then the V series is corresponded to this one here, because the B is connected in series. So resistor B is connected in series. So that means it is the one that must have a potential difference of 9 volts. But then the B has a potential difference of 9 volts and also as well as a current of 1.5 amperes, because it is connected in series to that ammeter. So if it's connected in series, that means the current is the same throughout. Now at this point, we do have the voltage, we do have the current. That means we can calculate the resistance using the formula R is equals to V over I. Now we say, what is our voltage? That's 9. And then what is our current? That's 1.5. And then if we say 9 divided by 1.5, we get 6 ohms. So that means the resistance of B, in other words, resistance of B is now equal to 6 ohms. Right, then that's how you could have got that one. Now, let's proceed to 11.5. So 11.5 is saying determine the energy, the energy transferred to resistor B in 10 minutes. Now we know that energy is simply just a power multiplied by delta T, right? So that's the product of the power and the time. So that means the formulas for energy, it's all the formulas for power multiplied by time. So we have the first formula for power is VI, so you just go VI delta T. And then the second formula for power goes I squared multiplied by R. Then you just put delta T. The third formula for power goes V squared over R. Then you just put delta T. Right. So that means to calculate your energy, you can use either one of these formulas, but then you have to make sure that you maintain that your delta T is always in seconds. Right. So we are given 10 minutes here, meaning the first thing that we have to do is figure out how can we write 10 minutes in terms of seconds? So we know 1 minute is equals to 60 seconds. So that means 10 minutes is equals to 10 multiplied by 60, which is 600 seconds. Right. Then to then calculate our energy, we can pick any formula here because we do have everything that we need for B, right? We do have the current for B, it's 1.5 amperes. We do have the voltage, we found it to be 9 volts. And then recently we just calculated in the previous question, our resistance, which is 6 ohms. So any formula that you choose here would actually work, right? So let's say we go with formula number 1. So that's W, and on our V, we substitute the voltage, which is 9. And then on I, we substitute the current, 1.5. And then for our delta T, we substitute our time in seconds, which is now 600. Now, if you multiply all of that, then you will end up with 8,100 joules, right? So essentially, even if you were to pick this formula or that formula, you would end up with the same value, right? You would end up with the same solution. So that's how you were supposed to calculate that one. And also note the SI unit for energy is joules. Then 11.6 says, how does the reading on V1 compare to the reading that on V2, right? So we have already dealt with that one. We saw that here we had a voltmeter reading of 1.5 volts, which we did conclude that also the voltmeter reading for this one is 1.5 volts since they have the same resistance and then they also have the same current by virtue of they are connected in series. So obviously they do have the same current. But then now the fact that they have the same resistance also leads us to conclude that they must obviously have the same voltage. So we are going to say for 11.6, the answer is supposed to be equal to, right? And then that's just how you were supposed to tackle this question for a total of 18 marks. So please play the video as many times as possible and try to understand the approach that I took into solving this question here. But then with all that being said, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.